Hello students, welcome to Swapna physics classes. In this lecture I am going to explain you one more essay question for your TS second year intermediate examination. Okay, before going to explain this answer, I just want to give you the basic idea of nuclear fission and nuclear fusion. What is this nuclear fission? The breaking of heavier nucleus into two or more nucleus. Okay, besides these two or more nucleus, a tremendous amount of energy is also released. And coming to nuclear fusion, here two or more nucleus are combined to form a heavier nucleus. Okay, with this heavier nucleus we will also have tremendous amount of energy, and this energy is utilized in our daily lives for producing electricity or for preparing nuclear bombs. Okay, here heavier nucleus is breaked into two or more nucleus, and in nuclear fusion two or more nucleus are combined or merged together to form a heavier nucleus. And this nuclear fission is used in nuclear reactors. Here I am considering uranium. I am taking uranium-92-235, which is a heavier nucleus and is combined with the neutron. This is combined with the neutron to form a uranium-92-236 nucleus, which is unstable and is broken into beryllium-56-144 and krypton-36-89. Plus 3 more neutrons are produced. With these 3 more neutrons we will also have 2 mega electron volts of energy. Okay, and because of this energy these neutrons will move very fast. And the neutron whichever we are using in this reaction is a slowly moving neutron. We have to take a slowly moving neutron. Okay, and after the reaction we are going to have 3 more neutrons which are fastly moving neutrons. If you control the speed of these neutrons, and make them to move slowly, what happens? The slowly moving neutrons again participate in the nuclear fission, and these 3 more neutrons will create 3 more neutrons each. Okko neutronu malli 3 more neutrons ni generate chestadi. Total we will have 9 neutrons, and these 9 more neutrons again participate in the nuclear fission, and these 9 more neutrons will generate 3 more neutrons each, and this reaction will be continued, which is nothing but a chain reaction, which is said to be a chain reaction. And how to control the velocity or speed of these neutrons? Let's see. And why to control the velocity of these neutrons? If fast moving neutrons only nuclear fission participate cheyava, why to take this slowly moving neutron only? I will explain. For example, I have a object and I had taken a gun and fired to this object. What happens if the velocity of this bullet which is traveling is higher and penetrates through this object? మనం ఈ వెలాసిటీ బుల్లెట్ వెలాసిటీ కనుక చాలా ఎక్కువ ఉందనుకోండి, ఎంత ఎక్కువ ఉండాలి, ఈ ఆబ్జెక్ట్ని పెనెట్రేట్ చేయాలి, అంటే ఒక చిన్న హోల్ చేసి బయటికి వెళ్ళిపోతుంది. ఇఫ్ యూ డిక్రీజ్ ద వెలాసిటీ ఆఫ్ దిస్ bullet, if you decrease slightly, what happens, this bullet will move or passes into this object and remains there itself. In the same way, for the neutron, if this is a nucleus, uranium nucleus, and if it is moving very fastly, if the neutron is moving very fastly, what happens, it will penetrate this nucleus. It won't break this nucleus, it will penetrate through the nucleus. If you take a slowly moving neutron, what happens, it will remain in this nucleus only. ఇది ఏమవుతుంది, ఇది వెళ్ళి దీన్ని కొలైడ్ అవుతుంది, కొలైడ్ అయిపోయి ఇందులో చొచ్చుకెళ్ళి ఇక్కడే ఉండిపోతుంది. And because of the repulsive forces, repulsive and attractive forces, what happens, this nucleus will become unstable. This nucleus will become unstable and will be broken into 2 or more nucleus. Okay, and after nuclear fusion, a tremendous amount of energy is released. A tremendous amount of energy is released, and because of this energy, these neutrons will move very fast. We have to control the fast moving neutrons. Then how to control the fast moving neutrons? Using moderators. Using moderators. A scientist named Chadwick suggested moderators for making the neutrons to move slowly. We are going to use moderators. Here the moderators we are using are water, H2O, heavy water, D2O, and graphite. You can use any of these. Why we are using H2O, D2O, and graphite? Why? Because if a fast moving neutron collides elastically, elastic collision takes place. And the size of these neutrons are same, that is hydrogen atom. Okay, the size of the neutron of hydrogen atom and this neutron are same, and the elastic collision takes place. And what happening here, exchange of velocity takes place. Here velocity is exchanging between these between these neutrons velocity exchange takes place. Why? Because for elastic collision, kinetic energy is conserved. Kinetic energy is nothing but half mv square. This is conserved. Here velocity exchange takes place in between these neutrons, but it is not destroyed. Okay, this fast moving neutron will move slowly with the velocity of this neutron. Okay, and this slowly moving neutron will move faster with the velocity of this neutron. Velocity exchange జరిగింది ఇక్కడ. Okay, in this way we can control the velocity of the fast moving neutrons. But what happening here, it is a chain reaction. That means the generated neutrons after nuclear fission will participate in the nuclear fission again and generate few more neutrons. Okay, and after that the generated neutrons again participate in the nuclear fission. Here few more neutrons are generated. The count of the neutrons are increasing here, and tremendous amount of energy is increasing. Here energy generated is increasing, and the explosion takes place. Finally the explosion takes place at some point. Explosion of the nuclear reactor takes place at some point. But we need stable energy. Explosion జరగకూడదు మనకి. అంటే ఇక్కడ ఏం కావాలి మనకి? న్యూట్రాన్ జనరేషన్ ఏదైతే ఉందో అది కంట్రోల్ కావాలి, అది కంట్రోల్ చేయాలి. హౌ టు కంట్రోల్ దట్? యూజింగ్ కంట్రోల్ రాడ్స్. We will use control rods. There are cadmium or boron. The material made with cadmium or boron are used for controlling the excess of neutrons generated. మనకి ఎన్ని న్యూట్రాన్స్ కావాలో అన్ని మాత్రమే మనం న్యూక్లియర్ రియాక్టర్లో ఉంచేసి మిగతా అవి ఈ కంట్రోల్ రాడ్స్కి ఈ కంట్రోల్ రాడ్స్ ఇన్సర్ట్ చేయడం వల్ల ఏమవుతుంది, మిగతా న్యూట్రాన్స్ని ఏం చేస్తాయి, అబ్జర్వ్ చేసుకుంటాయి. దీస్ కంట్రోల్ రాడ్స్ విల్ అబ్జర్వ్ excess neutrons. Okay, so in nuclear reactors we are using moderators and control rods. Control rods are used for observing excess of neutrons, and moderators are used for maintaining the speed of the neutrons. Moderators are used for maintaining the speed of the neutrons. Okay, and coming to the multiplication factor. What is this multiplication factor? It is denoted with K, which is nothing but the ratio of generated neutrons to the given neutrons. ఓకే, మనం ఎన్ని న్యూట్రాన్స్ ఇస్తున్నాం న్యూక్లియర్ ఫిజన్ జరగనీకి? న్యూక్లియర్ ఫిజన్ తర్వాత ఎన్ని న్యూట్రాన్స్ జనరేట్ అయ్యాయి? ఓకే, ద రేషియో ఆఫ్ జనరేటెడ్ న్యూట్రాన్స్ టు ద గివెన్ న్యూట్రాన్స్ ఈజ్ నథింగ్ బట్ ద మల్టిప్లికేషన్ ఫ్యాక్టర్. And if this multiplication factor K equals to 1 or less than 1 or greater than 1, the multiplication factor may be equal to 1, less than 1 or greater than 1. What happens if it is equal to 1? If it is equal to 1, the given neutrons will be equal to generated neutrons. Okay, and if it is less than 1, given neutrons will be less than generated neutrons. If it is greater than 1, the given neutrons are greater than generated neutrons. This condition is known as critical condition, and both these conditions are known as supercritical conditions. Okay, we have to bring the multiplication factor to be unity ఉండేలా చూసుకోవాలి. సో మనకి ఆటోమేటిక్ సిస్టమ్ కాబట్టి మనకి సిస్టమ్ కంట్రోల్ చేస్తుంది. ఎట్లా కంట్రోల్ చేస్తుంది అంటే బై ఇన్సర్టింగ్ control rods into the nuclear reactor. We can bring this K value to unity. We can bring the K value to 1, unity. Okay, and with the help of the diagram I will explain the working of nuclear reactor. What is the principle here? The principle of the nuclear reactor is controlled chain reaction chain reaction in nuclear fission process. Okay, and coming to the working of the nuclear reactor, we will have a core. Okay, in this core we will have moderator with the fuel. In this core we will have moderator with the fuel. Fuel is a uranium 92 235. Why we are taking this uranium 92 235 nucleus only? Why? Because it is easily available in our nature. That is the only reason. Okay, and we are taking the moderator. The moderators might be H2O, D2 or graphite. Okay, and around this core we will have a reflector. This is a reflector which controls the leakage of the radiation. This reflector controls the leakage of the radiation. Okay, and a coolant is attached. Coolant is attached to this core as well as the reflector. Okay, coolant and enti chala challati material, very cold material is passed through this coolant. Why we require this coolant? Because here the energy generated is nothing but a heat energy. Here heat energy is generated. Okay, and this heat energy here, whichever generator is given to this coolant. The material whichever passing through this coolant absorbs this heat energy, and this heat energy is given to the heat exchanger. This is a heat exchanger. In heat exchanger, what happens? We will have the flow of water, inlet flow. Because of the heat, whatever produced here is given to this water, and this water is converted into steam here. In heat exchanger, using this heat energy, we are converting the water into steam, and this steam is allowed to pass through the steam turbines. Here the steam is allowed to pass through the steam turbines to generate electricity. Listen carefully, I will explain once again. We will have a core, and in this core we will have moderators as well as fuel. Okay, and the system whenever requires it will insert the control rods, and it will remove the control rods. అవసరం ఉన్నప్పుడు అంటే ఎక్సెస్ ఆఫ్ న్యూట్రాన్స్ ప్రొడ్యూస్ అవ్వగానే, జనరేట్ అవ్వగానే కంట్రోల్ రాడ్స్ని ఇన్సర్ట్ చేస్తుంది. దీస్ కంట్రోల్ రాడ్స్ విల్ అబ్జర్వ్ ద ఎక్సెస్ ఆఫ్ న్యూట్రాన్స్ and it will be removed. These control rods will be removed by the system itself. Okay, then after, this core is surrounded with a reflector which controls the leakage of the radiation, and to this section coolant is attached, in which the condensed material is allowed to pass. This condensed material absorbs the heat energy which was generated in this section, and this heat energy is allowed to pass through the heat exchanger. In this heat exchanger, the condensed water are circulated. In this heat exchanger, the condensed water are circulated, and because of this heat, this water will be converted into steam, and this steam is allowed to pass through the turbines where the electricity is generated. This is the working of nuclear reactor. Okay, I hope you understood the complete process of the nuclear reactor, what is happening in the nuclear reactor. Okay, if you control the chain reaction, if you control the speed of the neutrons, if you control the excess of neutrons which was generated, then the nuclear fission takes place and the energy is released, the stable energy is released, whatever we required. Okay, the amount of energy we required is released, and this energy is in the form of heat energy. This heat energy is used to convert the water into steam, and this steam is allowed to pass to the turbines to generate electricity. Okay, and please subscribe to my channel, whoever didn't subscribe to my channel till now, and please share with your friends. Maximum people ki share cheyaniki try cheyandi, so that the subscribers count will increase. Okay, bye.